Hello, we are Team Mia and our project is aimed around replacing an existing bridge on Gratiot Road over Cooper Drain in St. Clair County, Michigan. Our sponsor for this project is the St. Clair County Road Commission and its engineers. Project location. We are located north of Detroit in southeast Michigan. The plan view on the right is an aerial shot view showing the existing Cooper Drain and its relation to Gratiot Road culvert. Background. The existing structure has a 14-foot span and is made up of continuous concrete footings and concrete abutments. A concrete deck is then placed on top of the abutments and are all cast-in-place concrete. Current project condition. On the left, you can see a picture showing concrete wing walls that have seen much spalling over the years. A picture on the right shows a lot of spalling on the concrete abutments underneath the deck and cracking and exposed rebar on the deck itself. The bridge will either have to be replaced or load posted, and load posting is not an option at this point due to the heavy traffic loads the road sees.
The flow data was provided by Eagle, and the 500-year flood map shows that even with a 500-year flood event, there is no overtopping on the roadway. Our design is an 18 by 8 foot box culvert, and with the original structure, the 500-year flood event would completely fill the opening with water.
After the main geometric parameters of the culvert were chosen, the structural design was started. The MDOT Bridge Design Manual specifies that an HL93 mod design truck be used in addition to other loads required by the AASHTO Bridge Design Specification. The structural analysis was done using RISA 2D with a 1-foot unit width of the culvert modeled as a plane frame. The loads were applied individually, and the resulting moment, shear, and axial forces were determined at several locations. Next, these loads were factored according to AASHTO LRFD loading combinations and superimposed. Live loads were patterned to produce the worst load effects in each element. These loads would then be sent to a precast concrete manufacturing company who would design the reinforcement.
Based on the drafted box culvert design, a 3D model was created in NX to show the road profile in relation to the box culvert. The model includes the HMA pavement surface, the subgrade, existing soil, guardrails, head walls, wing walls, and the box culvert. The second image shows the same model with the road surface layers stripped back for clarity.
So in summary, our bridge design will allow for heavier projected traffic loads in the future. It'll be able to withstand 500-year flood levels. It's cost-effective versus cast-in-place concrete or steel. It has reduced maintenance needed and also projected longer life expectancy.